All right. Hello, everyone. Welcome to the Provider AWS meeting on June 10th. We are going to start with a demo today, assuming we can figure out screen sharing, and then we'll move on to the agenda. So let me see if the option, okay, looks like I can make you co-host here, Pratik. So there we go. I think that should be enough.
Yeah, I'm able to share now. Cool, thanks.
Great. All right, go ahead and get started.
Okay, yeah, let me share my screen real quick. Okay, let me know if you guys are able to see my slides. Cool. So some of you guys might not be familiar with this project that I'm trying to demo today. It's a Kubernetes iteration toolkit. It's an internal project, although it's open source, and I just wanted to give a quick demo and get some feedback from the group, like what others think, if it might be useful, and if there are some other set of feature or functionality you guys think might be useful to add. So the idea here is I'll spend like initial 5 minutes just to go over the architecture and some background around what the project does and how it is being designed and why are we building this project, and then I'll do a quick demo to show how to start using it. In while I'm demoing or presenting, if there are any questions, feel free to stop me. So I'll start with what is Kit. Kit basically is it's a group of open source tools which are decoupled from each other to achieve their goals. Like I'll go over what these tools are, but at a very high level, it's a collection of all these open source tools and some of our custom code to create Kubernetes clusters. The reason we wanted to do it was we wanted to have an environment to be able to iterate over testing Kubernetes faster on EKS or on vanilla Kubernetes. So that was the goal why we started this project. What we are trying to solve is, as I said, as an EKS team or as scalability teams, we tweak too many flags. We have to check for the performance in Kubernetes or on the instances where Kubernetes is running. So we wanted to accelerate that testing and be able to get the results faster, because I'll show that in a second what I mean by accelerating the testing. So the goal here is all the configurations that we have for the infra, for the cluster, all the test cases, is all declarative, and it all lives in GitHub repo, and it all gets synced to these clusters. It's easy to iterate over. If you need to change a flag, it takes about 30 seconds to update a flag in your control plane, and then you can run test against that. And then if you need to swap out the instance with the larger instance or a smaller instance, that takes about 60 to 90 seconds based on the boot time for the instance, and everything gets configured based on that. So some of the use cases that we are trying to cover here, as a Kubernetes user or a developer, I want to create, let's say, X number of secrets. Now, each use case is different. Somebody might have a secret object, which is like 10 kilobytes. Somebody might have a secret object, which is like 1 MB, for example. So now there is a limit to how many secrets you can create in each of these scenarios. And you want to measure what my SLOs are when I'm creating, let's say, 10,000 secrets, 20,000 secrets, and how does it impact my API server? And if I change some flags on control plane or on etcd, does it impact the performance? And now I want to make sure that when these control planes are running on different instance types, let's say medium or up to like 24x large, how does that impact performance? Or there is no change at all when I'm changing these instance types or the EBS volumes. Now, as an advanced user, I have some changes that I make to the API server image, and I want to run that image easily and test my changes. But I want to now redo all the testing that I have done with the number of objects that I have created, the flag that I want to tweak, and also I want to run these control plane on different instances with my custom image. So there can be like these multiple iterations as a user or as a Kubernetes developer that you need to go through, which in some cases might cause delay. And as part of these testing, you're always checking out for how is my resource usage looking like, how is my latency, how is my SLOs. I want to collect all the logs and metrics from the instance level, from Kubernetes control plane and etcd, and be able to view them easily and quickly enough. So this was at a very high level the use case that we are trying to solve for. Just go over it. How are we solving it using Kit? So as I mentioned, it's a collection of these open source tools. At a very high level, we divide the whole toolkit into 4 components. One is your environment. Environment is basically a new VPC that we create where we configure everything, we run the tests, and we tear down everything. So we call it a Kit environment where we have a management cluster, and these management clusters manage your new test Kubernetes clusters. So you can bring up multiple Kubernetes test clusters in that environment and tear it down in the same environment. And then if you don't want the environment to be a long running environment, you can also tear down that environment. But the idea here is environment can be like a short-lived environment just for one single test, or it can be like a long running environment that stays for like days or months, and then you clean up later on. The second component that we have is an operator component that helps us create vanilla Kubernetes in 2 to 3 minutes on EC2 instances that are very closely designed as an EKS control plane, so that you can run tests against a vanilla Kubernetes cluster where you have control over how you change these flags, instance types, whatever configuration you want to change, you can change on these guest clusters, run some tests, collect results. Whenever you are satisfied that this is the flag value I want, you can we can then port it over into the EKS control plane and then run the test against the EKS control plane again. So the goal here is to iterate faster over these um, so that once we are ready with those changes, we can upstream those changes to EKS. The third piece that we have is that the CI pipeline. We use Tecton for it because it gives us ability to create these modular tasks, and we can reuse these tasks in different pipelines. And I'll go over some of these tasks to demonstrate why we chose Tecton. And the fourth final piece is Prometheus and Grafana. So anytime you create a test cluster, we configure Prometheus and Grafana to to scrape all the metrics from that test cluster. And Grafana comes preloaded in this Kit environment to visualize all the metrics from API server scheduler, KCM, etcd, and node level metrics. So you get all the metrics. So as a user who is getting started with testing, once they create an environment, they have all of this ready. And once they run the test, they'll be able to get all the metrics immediately. So so the idea here is you're not starting from scratch where you are coming. So when you need to test, you're not bringing up a new Kubernetes cluster. You don't have to install Prometheus. You don't have to write all the small test cases. They're already created in Tecton. You just need to create your pipeline based on what you're trying to test and get the results quickly. So how does a workflow look like for a user? User uses a kitctl to create an environment. So we added, in this project, we added a very small CLI. It's still very lightweight. All it does is creates an environment and deletes an environment at this point. I'll show that in a second, like how it creates it. And once the Kit environment is created, it consists of a management Kubernetes cluster, and it also installs all the operator that we need to manage the lifecycle of these clusters. These operators are Tecton, Carpenter, load balancer, CSI driver, whatever we need to manage these cluster. Prometheus Grafana also. It installs all of that, and then the user can go either use Tecton to run these to run the test, or they can manually run any test in this environment now. And then the fourth piece is to use the monitoring stack which we already deploy to scrape all the metrics from here. So at a very high level, this is how the architecture looks like. So once I bring up a Kit environment on top, it has a management cluster which has master components and etcd. And as a user on the left, I can talk to this management cluster, and Kit, when the environment comes up, it comes up with all these operators installed. Now, the next step is for me to test Kubernetes. Now what I want is, if my use case dictates that I want to test against an EKS cluster, I'll take Tecton to bring up an EKS cluster and run test against that EKS cluster, add some workload nodes, and collect all the metrics in Prometheus. Now, if my use case is to bring up a vanilla Kubernetes cluster, it doesn't have to be an EKS cluster. I'll tell Tecton to bring up a vanilla Kubernetes cluster of whichever version I want through a CRD spec. I'll show that, and then it will bring up a guest cluster. We call it kit guest clusters. These are vanilla Kubernetes cluster running on EC2 instances, and they use EKS distro images. And you can run the same test that you run against EKS now against this vanilla Kubernetes cluster. Now you have this control of changing all the flag settings that you want to change on a control plane or an underlying EC2 instance, whatever you want to tweak in these guest clusters. And same way, you can add workload nodes to this guest cluster and collect all the metrics and share all the metrics with us. So at a very high level, this is how the whole architecture looks like. And this is the link for the repo. I can put it in the chat. And let me go ahead and kick off the environment creation, and then we can discuss about any questions that we might have. So the kit CTL that I was talking about is a very lightweight CLI. It's in the kit repo only. And then the one of the commands that we support is to bootstrap an environment. This is my environment name, and it takes about 3 to 4 minutes. What it's going to do is it's going to create a VPC, all the IAM roles, security groups, routes, and whatever we need for this environment, NAT gateway, and the management cluster. So once this comes up, the end goal will be, we will have a Kubernetes management cluster, and all these operators will be installed on that management cluster. And then we can go to Tecton and trigger our test, whatever test we want to run, either against EKS or this guest cluster. So while this environment is getting created, if there are any questions I can answer, I'll be happy to.
I think my first question is just why, like, I would be interested in seeing some information on like why you chose to create. I mean, I don't know what you reused, if any of these operators are reused, but like a lot of this seems brand new. So, what was the issue with the existing? I could see like for cluster provisioning, there's like cluster API and kops and other tools, and then for testing there's prow. So like what was lacking with those? And maybe it's just you want some streamlined API for your use case, but like what was lacking with those that caused you to create a new project?
Sure. So
I'll just quickly clarify something on the Tecton jobs. They are both creating the target cluster as well as kicking off jobs or testing jobs. Is that correct?
Correct. Yeah.
Okay.
Yeah. So yeah, to answer Nick's question, I'll go component by component. So the reason we started with kit operator to bring up these guest clusters was we wanted a declarative way to start with and reconcile on the cluster state very quickly. Like, let's say, so giving one example, what we tested was when we change flag on a KCM, the QPS flags. Let's say I want to test a QPS flag value of 20 or a 50. We didn't want to wait for like longer and then reconcile much faster on the KCM. When I used kops, what I saw was when I was changing the flags on the API server or on KCM, it was taking around like a minute or 3 minutes, because I think they changed the instance. The whole launch template gets changed, and then it takes time for this update to reflect. But what we wanted was how quickly we can change it. So we went with this approach of updating the pod spec itself. So the only new component that we added here was kit operator. And what it does, it takes a CRD spec and converts it into a pod spec. And that pod specs are API server pod spec, KCM pod spec, scheduler pod spec. So everything is being managed by this management cluster at this point. Now, if
sorry, just to,
yeah, go ahead.
clarify there. So when you say EKS cluster here, it's not actually an EKS cluster, right? Because obviously you can't, as a user of the EKS API, I'm not allowed to configure QPS and things like that, right? For the Kubernetes API server, because that's obviously what we do at EKS. So, and I think you alluded to this earlier. When you say EKS cluster here, it is as close to an EKS cluster, like an EKS managed control plane, as we can get without it being an actual.
So, sorry, the voice got cut towards the end, but I got the first part of the question. So on the left that we have is an actual EKS cluster on which we can't change any flags. So this is the EKS actual management control plane against which you get the API server endpoint and you can run the tests you want to do. But on the right, which I'm showing the Kit guest cluster, it is not an EKS cluster. It is an EKS-like cluster, which is created using EKS distro images. Now, all the configuration for this guest cluster is being managed through a CRD file. I can show that in a second. And if you want to tweak any flags, you can only tweak in this guest cluster, not on the EKS cluster, just to clarify all that. Okay. So yeah, so since I triggered the environment here, now it's complete and it brought up the management cluster. It deployed all the operators that we need. At this point, I can go and access Tecton here. So there are a couple of steps that we are still automating, but at the end of the day, user will not need to do these couple of steps. So I'm just running a couple of these steps manually, like creating the pipelines in Tecton. And in the next release that we are going to do, or maybe in like a couple of releases, all these two steps will also be automated with the environment creation. So now that I have created, now that we have created the environment, what I can go over is to the Tecton dashboard, and it comes pre-populated with all these tasks that we need to run. So I'll go over a few examples. So let's say I want to test against an EKS cluster now. So that we have one task which will use the AWS CLI, create an EKS cluster. Now, once you run this test, it has parameters saying which version you want. So you can just, when you are running these tests, you can just give, I want a version 120, 121, or 122, whatever you want. And then all these are like modular tasks, like tearing down cluster, creating a Fargate profile, and tearing down the Fargate profile. Similarly, we have tasks like create me a Kit guest cluster, clean up the guest cluster, set up the control plane, run some load against whichever cluster you want, pod density test, and tear down these clusters. So these are like individual modular tasks that you can run, and how we run them is through pipelines. So we have these sample pipelines which are like easy to understand. We have descriptions also in there. So just to give you an overview of what these pipelines are doing, they are basically combining these individual tasks that I showed. So for example, the first pipeline, it is going to run a CL2 load test on an EKS cluster, which was created using AWS CLI. So in this, we are combining 3 or 4 tasks. The first one is to create an EKS cluster using AWS CLI. The second one will add some workload nodes. The third one will run some CL2 test, and then it will just clean up everything. Same way, I have this task here, which will deploy some pods on a Kit cluster. So it will create a cluster and it will run some pods. And basically what we are trying to test in this scenario is the pod ready times, because in some cases, what you want to do is to make sure that the pods are getting ready within 5 seconds. So the idea here is we will be having these pipelines, which are like sample pipelines, to just show like when you need to combine these tasks, you can either like tweak these task settings, like how you want to, whatever you want to test. Now, let's say you want to maybe create config maps. So you can combine a task to create an EKS cluster and create config maps and then clean up. So that could be like one pipeline. So that's the goal here. So I can go trigger these pipelines either using CRD YAML files, or I can just go in here and just trigger these. So I'll just trigger one just to show how easy it can be just to now test this. So what this pipeline is going to do is it's going to set up a control plane for us and then set up a data plane. Actually, I should have showed this also. Let me go back 1 second. So when I ran this pipeline, in the pipeline, we give the name of the cluster that we want. And because these are guest clusters, so we can manage, excuse me, we can manage which instance type is used to run this API server. So by default, we are using 2x large. But if you want to test it on, let's say, 8x large or 16x large, you can give any instance type here, what Kubernetes version you want to test, the number of pods you want to run. By default, we are doing 100, but you can do, let's say, 1000. The number of worker nodes that this test should add. So by default, we are adding 5 and then just run the test. So that's what I did here. What it is doing is it is going to create a control plane and then add some worker nodes to that control plane and then create the number of pods that we specified and make sure that those pods are ready within that time. And if they are not, in the end, we will just see a status here if it was pass or a fail. So like this, we are running like multiple tests using Tecton. And in the same environment, we have also installed Prometheus and Grafana, which is configured now to scrape all the metrics from here. So essentially, that's the goal. Like now, as these tests are running, you can also go to Grafana and collect all the metrics because all these dashboards are preloaded inside Grafana for you to collect all the metrics. So in the scalability team or the teams that are using it currently, how they are running it is they create these multiple pipelines in parallel with the configurations that they need to tweak, and they can run these parallel tests and collect all the results, and it saves a bunch of time for the developers and whoever wants to test these and collect all the results. So yeah, sorry, go ahead, Jay. I just saw your hand raised.
No worries. Actually, yeah. I wanted to know if you support some sort of like a matrix or permutations or variance type configuration. You actually just referred to this, like the scalability team runs, I think you said, different iterations, different scales and that kind of thing.
Yeah.
Is there a way to, I don't know if it's, I don't know, Tecton, but I don't know if pipeline is the correct object here, but is there a way to create like a matrix of different options and execute the pipeline for each of those permutations? Does that make sense?
Yeah. I'm just trying to think like what will be the right. So I think we don't have it, but at the top of my
Kind of like
mind,
if you could think about like GitHub actions, how you could set up like a workflow to have like a matrix of different operating systems and image architectures and stuff like that, and it'll just sort of make a set of test jobs that correspond to each of those variants. In other benchmarking projects, I've seen similar ability to create those set of expected permutations that you'd like to test.
Yes, I think we can run that, and the way would be like you create one single pipeline and then you run these individual tasks, and you can run those tasks in parallel. So let's say you're trying to create a Kubernetes cluster with version 120, 121, and 22. You can create, you can have a pipeline. Now in that pipeline, what it will look like is when this pipeline is running, it is setting up a control plane for 120, 121, and 122 all in parallel. And then you would also see data plane creation for all those 3 runs together. So yes, you can do that, but it really depends on the use case, whoever is trying to solve for that and what they're trying to test for. So the goal, sorry, go ahead.
Unfortunately, I've got to hop into another meeting. This has been great. I'm really glad it's recorded because I want to share this with the ACK team.
Sure.
So, thank you all. See you. Bye.
Thanks. Yeah, if there are any other questions, I'll be happy to answer. Right. I guess if not, yeah, that's the end of my demo then. Thanks, everyone.
Cool. Thanks for doing that, Teek. Really appreciate that.
Thank you.
Thanks.
Right. We'll hop over into the agenda. So let me share screen. All right. Great. So first item is looks like issue 400. Where's the image for 122.3? Yeah, I think somebody pointed this out to me yesterday, so I was going to promote 122.3 today, and hopefully we can resolve this. I'm guessing, Cyprian, you wrote this one?
I wrote all 4, I think, so it's pretty easy. The thing is that none of the releases from 2 weeks ago were promoted, I guess.
Mm-hmm. Yeah, I might
so well, yeah. Plus the change log is still work in progress, I guess, for everything.
Okay, did we not merge the change log? I guess we didn't because we still have alpha. Okay.
Yeah, because we were releasing stuff and then that was not updated and so on. So
okay, yeah, this PR still, I thought this got merged, but so what are we waiting for? Okay, I guess we just dropped it. 122.3 got released, should just be updated as well. Okay, yeah, so let's just get this pull request to be completely up to date with whatever's there. I guess we'll promote first, make sure it's up to date, and then
okay.
Yeah, so let me just take a note here. Promote. Yeah, I just haven't had time to check on this repository in a week or so.
No worries. Just
Cool.
So just wanted to. Sorry, go ahead.
Please. No, you go.
Okay,
No.
just wanted to quickly understand what's the issue here. Like we are missing an image for 122.3.
So we didn't promote it. Basically, we go ahead.
We're missing more images. Pretty much a bunch that were released some time ago.
Yeah, so we
It's
created
not a
some
big
releases. Is it more than what else is it?
I think it's about 3 releases. They were all created. I don't know the reason, but I think they were after the tagging controller got merged and then fixed.
Right. Okay, yeah,
So this should include.
It's all of these. I think it's these 3. Yeah, this was like a rush to create these releases because Sorov needed it for tagging controller, and I never got around to promoting the images after that. So
Is there a documentation I can go read? Like, how do we manage that? I'm just curious to learn, like, how do we manage these
releases?
Yeah, like you said, promoting and.
Oh, the promoting part is probably separate, but let me show you what our docs have. We basically just have some documentation on and promoting. Yeah, I guess we just link what you need to do. So there's some stuff that needs to happen in basically adding the SHA of the image to this file.
Oh, I see.
And then the promotion will happen to the production.
I see.
Where's
Official Kubernetes registry.
Yeah. Yep.
So if it is not promoting, then how are those guys using it? The tagging controller, like, are they not using it from the
So-
production?
Yeah, so the reason that this is not ideal is that so we import from GitHub and then we have our own builds, right?
Mhm.
So like the build that they're using is happening internally to EKS.
Oh, I see. Okay,
And that's
makes
fine.
sense.
And sometimes I forget to go back and like update the GitHub release and stuff. It's just an unfortunate manual process that you know, we need to take more care. I mean, if we also like, there's probably more stuff we can automate here if we spend some time. Yeah, I don't know though. I like promoting the image. I don't see there's a way because like you have to, you know, update
Yeah,
this Kates.io repository. So
got it. Okay, thanks. Yeah, that makes sense. I just wanted to
Yeah.
understand the flow.
the one thing that I was thinking of is we can for the change log, like we could probably have a test in the change log pull request, like a pre-submit that checks to see if the images are present.
Mhm.
I imagine we can do that without permissions, just like go against the GCR API or something like that. And just see if like the image that you're trying to update is present before the change log merge. So at least we won't merge because I think that was the problem with the issue that was called out in, or maybe I'm not sure.
I think the bigger issue is not doing the Git release,
Promotion?
GitHub release. No. The go to releases in GitHub. Here you see you have the edit thingy
Mhm.
near top right corner. Technically, we could make this a draft.
Oh, so you're
And
saying not publish it until
people not publish it. People get notified when this is published. And if they want to try it, then, I mean, I doubt that anyone checks regularly the changelog. But this releases, if
I
you're
see.
watching the repository, you get notified and then you see that there's no image. So this could be created without being published. And once the promotion PR is available, they could be also published. Yes.
Yeah, that makes a lot of sense. Let's add that to the promoting the image to prod. And in fact, yeah, we don't say that after the release. Okay.
It's a Git action workflow that does the
Right.
release publishing.
Yeah. Okay, I forgot.
Once there's a tag, you get that automatically.
Forgot about that. Okay, cool.
Plus, you may also want to use that new stuff from GitHub that automatically generates some commit log between tags. Automatic release notes is called, so it basically shows you a diff between previous and
Right.
that
Yeah,
one.
we have that script that does it, but if GitHub has something automatic, we might as well use that.
Let me show you how it looks for KOps. I think we use it for newer releases because we don't want to copy paste it anymore. I mean, it's decent.
Git releases its draft until promotion. And then we should also come up with a mechanism to make sure we remember to promote. Okay, got some action items there. I think that should cover it. 388.
Well, it's the release tagging PR
Oh, okay.
that you reviewed.
Okay,
At some point, we have to test it, that it works, and we didn't do any release. I cherry picked it today to just they're on hold, but we need to do a release at some point to check that it works as we want.
Yeah,
I would say before approving the cherry picks.
Yeah, makes sense. All right, if we haven't, I mean, if we have new commits, then we can go ahead and try a release for 124 today, even. Yeah, sounds good. Skip reporting network interfaces created by pods. Is this yours as well?
Yeah. So we received some issues, and we noticed also in some test runs that CCM starts reading also the addresses of pods created by AWS VPC CNI. So these are pod ENIs.
Yeah, I was actually considering bringing this up in the so basically what the problem is that you need a pull request a patch basically that's not quite merged yet. So let me see if I can find it. So that this is basically due to the fact that the node IP flag in kubelet. Let's see if in my recent notifications.
Yeah, I think I know what you mean. There's an annotation or something with that.
Yeah.
The node I think if you set it as node IP when you start the kubelet, right? That's what you mean?
Correct.
Well, that is one thing, but CCM should somehow differentiate between those interfaces. There are two functions. One goes through IPv4 interfaces and the other through IPv6. So I guess maybe there's a way to recognize the VPC CNI ones or to recognize the node ones. At least from metadata, you could have gotten the primary IP address, I guess, or I don't know. I guess there are cases for people to create more than one interface, but
yeah, that is a good thought. I do believe that it's always primary for the node IP and then secondary ENIs for everything else. So there probably is a way to differentiate. Yeah, my question would be, are there exceptions? And you know, for yeah, there's a lot of different cluster configurations out there. So do we want to check to see that it's actually managed by the AWS CNI first before we make assumptions about the IP addresses? And but I do like the idea. Yeah, so this was the issue that I was talking about. Basically, you give the CCM the node IP, and the problem is that right now, this only is provided when kubelet has cloud provider equals external. But the fix to upgrade is that you have all kubelets set this annotation. So you know, and the reason this helps is because those secondary NIs and IPs are filtered out when the provided node IP is set to the, you know, whatever the primary IP address is.
But I think these are filtered by Kubernetes, right? Not by CCM. And
Correct.
in
Yeah,
CCM,
this is solving the problem in Kubernetes itself rather than teaching CCM about the differences between the IPs.
last time, which was half a year ago that I checked this code, it did a lot of work around, I don't know, clusters without CCM, the external CCM, and very little for those with CCM, external CCM. So basically, whatever you were giving to Kubernetes, it wasn't filtering anything. So maybe someone changed something here, but
yeah, it does do the filtering when CCM is present. But again, that's it's only when you have this annotation. So this annotation is supposed to be the alternative to the flag for kubelet. When you have CCM enabled, like that, before this annotation existed, there was no way to filter addresses. So there was only the way to do it with kubelet, and then CCM had nothing. So this annotation was added to give CCM that same behavior. But the problem with the existing behavior is that the annotation was not added to kubelets unless they had cloud provider equals external. And when you're upgrading, you don't, right? So the upgrade case was still totally broken because the kubelet and the CCM would fight over what the node addresses should be. And because one has the node IP flag and the other one doesn't, you'd get just the node IP, and then you get all the IPs, and then just the node IP, all the IPs. So that's what this reference to the node addresses flapping is. And then, but if they both,
I understand.
Yeah. So that's a fix. It's also not ideal in the sense that they shouldn't be fighting at all, but that's much bigger change. So this at least causes them to agree.
Unfiltered everything from CCM is not always ideal. Like it was in the case of IPv6, we wanted, like when I say I want IPv6 IP for node, it didn't know that part until we added that flag to CCM. If you would do the same without external CCM, then it would have worked. It was code in Kubernetes that was switching. You just had to say that you want an IPv6 address there in node IP. So yeah, I think there are still quite things to fix on this side, probably. Probably when things are closer to disabling in three cloud providers, people will notice differences more, I guess.
Yeah, well, if you have the IPv6 issue that you just referenced, I don't know that I'm familiar with that one, so that would be good to bring up. But also probably creating an issue for this. Like I like the idea. I don't know how we, you know, I think we got to think about, like, do we just do this in the specific case where we know that AWS VPC CNI is running, or, you know, is this always relevant? But let's create issues for these, especially if you know, I mean, assuming there's not already one. And then we can investigate and get it fixed.
Okay, yeah, maybe we can make it more generic or something. Doesn't matter.
Yeah.
Cool.
Yeah. But I like the idea. So I'm just gonna put assuming okay, I'll just do, is your last name K-M-A-N? All right, so go ahead and create the issues if they're not already there, and we'll investigate further.
Okay, sounds cool. Thank you.
Cool. And I think the changelog update was just a reference to.
If you want, you
Yep.
can remove that part and this last one.
Yeah, I think I got it covered up here. Okay. Cool. Anything anybody else has before we end? All right, I think we are done.